on the discussion of this organizer molecule, I think that we try to take a crack on the number 3 signal here. Okay, number 3 signal. Okay, right. Okay, so these are the secreted molecule. People love to study this secreted molecule because it has much more effect. So one of the example, the noggin really expressed in this Spemann organizer. They check the whether they are really coming from that. It could be accidentally incorporated in there. Then you need to eliminate everything. And what they found is that those number 3 signal, they found the partner. Okay. And then the partner was these, okay? Especially this chordine, noggin, follistatin I'm going to talk about. There was the BMP was their partner. And then turned out to be their, inhibitor for this BMP. So that's why they found this, okay? Noggin, chordine, and follistatin are the dorsal mesoderm and then neural inducer. Okay, dorsalizing factor, and then the neural inducers. Okay, so because the here's the dorsal, so around the dorsal neuron is the induced. So that's why they are neural inducer. And Hans Spemann's experiment, you transplant this to the other side, isn't it? And then you are able to find out the induction process by the Spemann organizer. Okay, so they look at the expression of this BMP4 and then X-Wnt8. Let me see what is the X-Wnt8. So let's go back here. Okay. So yeah, X-Wnt8 is actually the V force, isn't it? So ventralizing force. So we are looking at the number 4 forces, okay? Okay, they are number 4, okay? And they are basically everywhere. Let's look at the BMP4, really everywhere. And then X-Wnt8 is all over the, mesoderm, isn't it? But somehow, so what does it mean? Number 3 is everywhere. Number 3 is only in here. Number 3 is only in here. But number 4, okay, let me change to number 4. And number 4 is everywhere, isn't it? So it was so strange, okay? So they did this very critical experiment. I will put number 4 star and then times 2, okay? Then the power of 2, okay? So it's important, okay? And this BMP4 and X-Wnt8, number 4, are ventralizing and anti-neural factors. So it's not a neural factor because in here, right? But the what happened is you did an experiment, okay? So what you did is that, okay, you was it the make the dominant negative BMP4. I think this dominant negative is like is a BMP4R, means that BMP4 receptor. And then this is the basically the fake receptor. You just dilute the function of this BMP4 receptor. And then what you found was the if you do that, then the ventral mesoderm changed to a dorsal mesoderm, and then ectoderm was changing into the neural tissue. So if you block the BMP4, so that is the actually blocking, okay, number 4, then you are able to change a ventral, ventral to a dorsal structure, isn't it? Ectoderm and then neuron, because ectoderm is the, if it's not, they're all gonna be epidermis, but they are taken to. So you do the animal, CAP assay, okay? And then what you did is that, okay, so let me just turn off this for a while, okay? So you do the same thing with the animal CAP assay, okay? You have this, I'm talking about here now, okay? Right here. Okay. And then you add the dominant negative BMP4 or BMP4 receptor, you put it there, and then animal CAP ectoderm turning into a neuronal tissue. But what is really important thing is that with or without inducer. Okay, so without inducer, you take the animal CAP much earlier. Okay, I'm doing this. Okay, and then you have you put it in a culture dish, and then you put this animal CAP. Animal CAP here, and then you place the media, and then you're growing them. Okay, right, and then is the dominant negative BMP4 blocked, then they'll all turn into a neuronal tissue, which is the dorsal. Okay, but in here, people believe that this number 3 is a dorsalizing factor or something, but with or without the neuronal tissue, neuronal inducer, they were still able to form into a neural tissues, dorsal structures. Okay, right. So how does the neural inducer work? Number 3. And then why is the default state of the actor? I think that's we need to think about this. Okay. So from this, dominant negative BMP4 receptor, and then dominant negative BMP4, and then they're all turning it into a ectoderm, isn't it? And then the final conclusion is that in the animal CAP assay, you with or without the neural inducer, you are still able to induce the dorsal neural tissue, which means that neural inducer you don't need, isn't it? Right. So and then the if they don't have neural tissue, number 3, and then also they don't have number 4, isn't it? That is the situation. Let me see. So this situation here, this is no number 4 and no number 3, isn't it? No number 3, no number 4. Without the neuron inducer, right? Okay. Then they are neuron, which is dorsal, isn't it? Right. Which means there's a default. See, number 3 and number 4 are crashing together in previous term. Then you take out number 3, then all number 4. Number 4 will dominate. And then you take out number 3, then number 4, then number 3 will dominate, right? But in this case, without number 3 and then without number 4, what will happen? There's still number 3. So so ectoderm is, which means that the original fate of ectoderm is what? Neuron, right? If there's no signal, then default is neuron, okay? And then there are the reason why some of them turning it into a neuron, and then some of them turning into epidermis is because they are, crashing together and then balanced together. So then the question, the first question, how does the neural inducer work? Number 3, it's there, isn't it? And then how those number 3 works is most likely they are the inhibitor. So number 3 is just to, the purpose of number 3 is just inhibitor of number 4. So the reason why they have a number 3 is to block number 4. So number 3 doesn't really actively change a certain cell into a neuron. All they need to do is to block number 3, and the cell itself know how to turn it into a neuronal cell. That's what they. I think that's what you know. That's kind of like essence. You know, the this message in here, because our ectoderm is originally default is all neuron. The reason why they are turning it into ectoderm, you know, other ectoderm is because of the ventralizing dark force. Okay, and then number 3 is the blocking. Okay, so those you know protein, chordin, nogin, and then the follistatin is actually they are very similar to BMP4. Okay, and then all they do is that going in there and block the BMP4, just messing up their signal so that they keep their original or default fate, which is good for them, I guess. Okay, so this is overview. You know, VegT makes the endoderm, right? And then what will happen? Induction occurs. So, you know, number 1 signal and the number 2 signal. Actually, they are same thing, the higher amount than the number 1, right? So that is specifying dorsal mesoderm, which is a Spearman organizer, and here's the ventral mesoderm. And then after that, what is it? Number 3, the crashing signal. So number 4 signal is the BMP4 and X28. And number 3, well, you find the nogin, chordin, follistatin, activin, whatnot. You know, those guys kind of get crashing together like this, and then patterns, mesoderm, also produces neuron here, isn't it? Okay. The bottom line is what? Number 3 is just the blocking and inhibiting number 3 so that they can just keep their original fate. So that's why they can have the dorsal structure. So, okay. So that is the evolutionarily conserved. Okay. So DPP is actually in fly, isn't it? This is fly in a DPP dorsalizes embryo, and the SOG is preventing it. So SOG is a neuron inducer. It's kind of like a number 3 signal, okay? And then DPP is the you know, number 4 signal. In fly, dorsal and ventral is switched. So in not it's not like on was it the vertebrate. Vertebrate dorsal, you know, CNS. Our CNS runs the dorsally, right, on the back. But the fly, their CNS, the nerve cord, okay, their spine runs through the ventral on the belly. Okay, so so dorsal is the DPP is anti-neural. Is it neural? Did I spell it right? Okay. I'll just okay. Embarrassing. Okay, neural. Okay. Okay, and then what is it? And then anti-neural, and then also what is it? The yeah, anti-neural signal, and then dorsalizing. This is the dorsalizing, but they are dorsalizing because it's switch. But SOG is what? SOG is the ventralizing factor, right? And then the you know dorsalizing factor, and then neuronal factor, neural inducer, neural. I think there's ventralizing, I would say just vent, and then neural inducer, isn't it? Number 3 in the fly, but the in the with a frog, BMP4 ventralizes embryo, and then the number 3 signal dorsalizes embryo because the this axis is like flipped. Okay. So yeah, here. So anti-neural ventralizing in Xenopus BMP, right? And then that is blocked by chordin. This is the you know, what is it? The neuronal factor number 3, right? And so SOG is the same thing. So it's a neural inducer, and then blocking DPP, which is the anti-neural, but that is the dorsalizing. Okay. I heard that you can exchange a little bit, you know, So this thing, I'll just leave it up to you. I think that's the slide itself is very self-explanatory. So I have finished with the lecture 16 also. So I'll meet you in the next segment, which is the lecture 17. It's a totally different subject. Thank you.